Hello, happy people. This is Mr. Wilcox. This is the first video for Algebra 2. If you're ever gone, this is a great way to get your notes. I'm just going to go through the lesson like I would have in class. And so, our first chapter in Algebra 2 is all about learning what we did in Algebra 1, just so we're ready to go for the rest of the year. So, first thing we're going to review is solving equations, because that was a big part of Algebra 1. So, I'm going to have some steps for you, and then I'm going to have lots of examples. So here are the 3 steps we're going to follow today to solve equations. If you have not taken the notes yet, this is a great time to pause the video and write this down in your notebook. All right, the steps we're going to take to solve equations. We're first going to check each side of the equal sign to see if we can simplify by distributing to get rid of parentheses or combining any like terms. Remember, like terms are any variables to the same power. So like an x and an x, or an x squared and an x squared, or a constant like 9 and 7. And so if we have 2 of those on the same side of the equal sign, we're going to combine them. So after each side of the equal sign is simplified, we're going to make sure our variable is on one side of the equal sign by moving a term with the variable if we need to by adding or subtracting. And then once our variable's on one side, we can solve the equation, which means getting our variable alone, and it needs to be positive, and it needs to be equal to a value that makes the equation true. So our first example, we're going to start simple, and we're going to work our way up to more complicated. So we're going to start with 4x plus 9 equals 21. So following our steps, if we look at the left side, we have 4x plus 9. 4x and 9 are not like terms because 4 has a variable x and 9 does not. And then there are no parentheses, so we can't distribute. On the right side, we just have one term, which is 21. It's as simple as it can get. Step 2, make sure the variable is only on one side. Well, in this case, it's only on the left. And step 3, we can solve. So in Algebra 1, we made you write out all the intermediator steps with showing your operations. In Algebra 2, if you don't want to show those steps, you don't have to. So I'm going to show you what that means. So to solve 4x plus 9 equals 21, the first step you take is to subtract 9 from each side, because that's the inverse of adding 9. In Algebra 1, we made you put a minus 9 and a minus 9 on each side. In Algebra 2, if you want to skip showing that step, you can. So if we subtract 9 from each side, we're going to get 4x equals, and then 21 minus 9 is 12. So if you don't want to show that the actual operation of subtracting 9 from each side, you don't have to. If you want to, that's fine. Your work will be that more accurate, and all the better for it. All right, so to solve 4x equals 12, our next step is to do the inverse of multiplying by 4, which is dividing by 4. So if I divide each side by 4, on the left I get x, and 12 divided by 4 is 3. So I have my variable x, it's positive and equal to a value, so that is our solution. I'm not going to make you check every solution, but remember you can check your solutions by plugging them back into the variable into the original equation. So if I plug the 3 value in for x and then simplify, we can make sure that our solution is correct. So now I just have to simplify by using the order of operations. So I'm going to multiply first. 4 times 3 is 12. And 12 plus 9 is 21. And does 21 equal 21? Yes, indeed. So my solution of 3 is correct. It is the one value that makes this equation true. Again, I'm not going to make you check all your solutions. I'm just going to show you this one. But you can check any solution by plugging it back in for all of the variables and then making sure, simplifying both sides equal sign to make sure they are equal. So you should be able to get 100% on this assignment. All right, so let's bump it up to a little bit harder by adding a fraction in. So following our steps, our first step, there are no like terms or parentheses on the left side. There's no like terms or parentheses on the right, so we are simplified. Is the variable on one side? Yep, it's only on the left. So now we can solve. So what's the inverse of adding 1? Well, that is subtracting 1 from each side. So if you do that, on the left, we're just left with negative 3/5 x. And on the right, 4 minus 1 is 3. I am going to show this step here because it is something sometimes we struggle to remember how to do, and that is dividing by a fraction. So division by definition, anytime we divide, all we're really doing is multiplying by that number's reciprocal. So same with fractions. So to divide by a fraction on each side, I'm going to multiply by the reciprocal. And to find the reciprocal of a fraction, I just need to flip it over. So I'm going to multiply each side by a negative 5/3 because that is the reciprocal of negative 3/5. So the negatives cancel out, our 5s cancel out, our 3s cancel out, and that leaves us with just an x, which is what we want. And if I take 3 times a negative 5/3, it's 3 over 1 times 5/3. My 3's cancel out, and I'm left with negative 5. So I have a positive variable equal to a value. So that is my solution. X equals negative 5 is the one value that makes this equation true. All right, let's bump it up a little more by having variables on both sides. So first step is still to check to see if we can simplify. So 5z minus 2 on the left. 5z and 2 aren't like terms. There's no parentheses, so it's simplified. How about 3z minus 4? Well, 3z and negative 4 aren't like terms, and there's no parentheses, so we're simplified. Second step is variable on one side. Well, it's on both sides. So there's two things I could do. I could either subtract 5z from both sides, or I can subtract 3z from both sides. I always err on the side of making a positive coefficient, but it doesn't matter which one you do, you will get the same exact answer. But because I like a positive coefficient, I'm going to subtract 3z from both sides. So a 5z minus 3z is a 2z. I still have a minus 2. And if I subtract 3z from 3z, I'm left with 0. And meaning it cancels out, leaving me with just a negative 4. Now that the variable's on one side, all we have to do is follow our rules to solve. So what's the inverse of subtracting 2? Well, that's adding 2. And so if I add 2 to each side, I get 2z equals a negative 4 plus 2 is negative 2. And if I divide both sides by 2, because that's the inverse of multiplying by 2, I get z equals negative 1. So I have my z all alone equal to a value. So negative 1 is the one value that makes this equation true. All right, we're halfway done with examples. Let's bump it up a little more by throwing in some distributive property. So both the left and right side have parentheses. How we get rid of parentheses is using the distributive property. And hopefully you remember the distributive property means to take whatever term outside the parentheses and multiply it by every term inside the parentheses. So 3 times x is 3x. And 3 times 2 is 6. On the right side, if I take 5 times x, I get 5x. And if I take 5 times 4, I get 20. Are there any like terms? Well, 3x and 6, nope. 5x and 20, nope. So we are simplified. So getting the variable on one side. Again, I have two choices. I can subtract the 3x from both sides or the 5x on both sides. I know if I subtract the 3x, I'm going to get a positive number. So I'm going to subtract the 3x from both sides. So that means on the left, I'm just left with 6. On the right, 5x minus 3x is 2x. And I still have a plus 20. So now I just have to follow my rules of solving. So the inverse of adding 20 is subtracting 20 from each side. So 6 minus 20 is negative 14. And on the right side, my 20s cancel out, leaving me with just a 2x. So now if I divide both sides by 2, I get negative 7 equals x. So I have a variable by itself equal to a number. It does not matter that the number comes first. This is my solution, negative 7 equals x. Let's bump it up one more. Let's add a like term. So on both sides, we still have to distribute. So let's do that first. So on the left side, if I take 3 times 5x, I get 15x. And if I take 3 times negative 8, I get negative 24. If I distribute my negative 2 on the right side, negative 2 times a negative 1x is a positive 2x. So remember, there's a hidden 1 there, so that's really a negative 1x. If I take negative 2 times a positive 7, I get negative 14. And then I still have a negative 12x following. So here on the left side, I have no like terms, so that's going to stay the same. On the right side, however, I have a 2x and I have a negative 12x, and I can combine those because they have the same variable to the same power. And if I combine those, I get negative 10x. All right, so now I have no like terms, no like terms, no parentheses, no parentheses. So is the variable on the same side? Nope, it's on both sides. So I have 2 choices. I can subtract the 15x, or since this is a negative 10x, the inverse of that would be adding 10x to both sides. That is what I'm going to do because that's going to keep my coefficient positive. So 15x plus 10x is 25x. And a negative 10x plus a 10x cancels out, leaving me with just a negative 14. So now I have variable only on my left side here. So I'm going to follow my rules of solving. So I'm going to add 24 to both sides since it's the inverse. So I'm going to get 25x equals, and then negative 14 plus 24 is 10. And I'm going to divide both sides by 25. And 10 divided by 25 would be 2/5 or 0.4, however you want to report that. I like to keep it as a fraction because fractions are always the exact answer. 0.4 is also an exact answer here, so I wouldn't mind. But if you get something like 2/3, I do not want you turning into 0.6 repeating. I would rather have you keep it as 2/3. So leaving things as fractions is always accurate, where turning things into decimals isn't. So I would prefer you keep it as a fraction. All right. One last example. So we're going to do an example where we have to combine like terms with fractions, and then we are done. So first step is simplifying. Well, I have 3/4 x and 1/2 x. Those are like terms, and I'm adding them, but my coefficients are both fractions. And remember, to add fractions, we need like terms. So I'm going to throw in the step of showing where I get my like terms. So here my denominator is 4, and here my denominator is 2. So the lowest common multiple of both 4 and 2, so the lowest number that 2 and 4 are both going to, is 4. So I'm going to write my denominator as 4 and change anything I need to change. Okay, let's try that again. Denominator of 4, denominator of 4. All right. So 3/4 stays exactly the same, but to get my denominator before here, I must have multiplied my 2 by 2. So whatever I do to the denominator, I must do the numerator. So 1 times 2 is 2. So now I'm ready to add my fractions to simplify. So 3/4 plus 2/4 x equals 5/4 x. Because remember, when you add fractions, you add the numerators and keep the denominator the same. So now again, how do we divide by a fraction? We multiply by its reciprocal. So the reciprocal of 5/4 is 4/5. And again, I'm going to show this step because it is something we forget how to do. So 5's cancel out, 4's cancel out, so I'm going to get x equals, and remember this is 3 over 1, so 3 times 4 is 12, 1 times 5 is 5. 12/5 you can't simplify in the sense that 12 and 5 aren't divisible by any of the same number, so you can leave your answer as 12/5. You could make it 2 and 2/5 if you wanted to make it a mixed number. You could do the division and make it a fraction, or a decimal, but again, you can keep it as improper. That's fine. So 12/5 is a good answer. All right, so that's the last example. Your homework is on page 21. If you're not at school, it is actually, if you go into the assignment part under Brightspace, I have taken a picture and added it to the assignment so you can see all the problems. So even if you don't have a book, you can still do it. All right, I hope you all have a great day. Cardinals, make it count.